Well, this is a bit difficult or different morning since there's absolutely no one besides me on these lectures here present, but I'll give the brief talk about today's topic anyway, since I know that at least some people are still watching the course lectures on the internet recordings, and I guess that way I'll at least get through to some of you. So it may seem a bit, weird looking if someone's looking at this lecture hall, since I'm here just giving a speech to an empty hall. But anyway, so today's topic is Agile methods. From last week, when we did the first step towards actual program, the idea was that once we get all the requirements gathered and we have defined the use cases for the project we want to implement, we do this BCE design, boundary control entity design, to get more implementable design of the software. The BCE design model is also called entity control boundary pattern, but since the rationale itself uses the BCE design name, I'll stick to that because the rationale is also the company that has defined the unified process model, and also the company which has defined the UML definitions. Before we go to the Agile methods, let's just go through a few of the things about the BCE design which weren't mentioned last week. Overall, the idea is that from the abstract models, we go to analysis classes, go to actual design, logical views, and design all the different things which are needed to create source code and compile it to executable code, which can then be which can then be tested and released. But on the BCE model itself, there's a couple of things that should be mentioned or understood. First of all, the BCE is still quite far away from the actual implementable design. And the BCE classes have some evolving to do before they can actually be implemented. And for example, in the design of boundary classes, the boundary does not represent one class or one component. It's more or less an abstraction which defines several different subclasses or subdivisioning of the entire user interface. Like in this example where we have file browser boundary. It could be something that any user uses, it could be something that customers use, but still it includes all the things, for example, from Windows user interface. The Explorer window, which has status bar, which has a tree view for the files and folders and stuff like that. Also, tool area, list items, all the things in the currently selected folder. So, considering other example like a browser window, it could also include address bar and the page itself, also the components or applets or JavaScript forms, which can be used to get or collect information from the actors, users, and used to submit it to the system itself. So boundary during its lifetime or its analysis lifetime is first designed as one contact point into the system, and then when it's actually implemented, it contains all the things needed for functionalities and views and forms and things like that. Similarly, the control class is also something that evolves. The control class usually just melts away, meaning that it's more or less just it's an umbrella under which all the different actual classes which control the network adapters or database handlers or complex calculation libraries, things like that happen. So the control class from the BCE model usually distributes its functionalities and information to a number of different other classes which do things like transaction management, distribution, calculations, graphics engine, or 3D engine, physics engine, even if we are talking about things in games industry. So the control class usually is more or less an system or environment itself. The entity classes are the one which is actually the most closest to the actually implemented things from the group of BCE classes. Its design, of course, changes to suit the abilities and requirements of the database, which is used database middleware, meaning the software or the layer which controls the actual physical database. Of course, for performance needs, like in large online service, there may be some requirements for optimization or ability to distribute the data so that it's accessible even though if one branch of the system is not available. But in any case, the entity class is the one which most closely resembles the actual implementation. And overall, there's a few easy things that should be remembered for the BCE model connections. Of course, every boundary is the entry point into the system, and the user interface has to be connected to something that actually does things. So basically, that means that boundary can only contact more or less control classes. The control is the core of the system, and it can connect to anything. And the entities, which are more or less just data bases or data dumps, they need something to extract the data or manipulate the data, so they only connect to the control class. So that's the idea with the BCE models. Also worthwhile to notice is that unless your users are programmers or developers who manipulate the source code itself, all the actors should always be connected to boundary classes, because boundary is also the user interface. Okay, so the idea is that we are going through the different phases of rational unified process. At the start of the course, we started from the general topics before getting into this actual development workflow, but now we have more or less collected the requirements and made some elaboration on how software is developed. And the time of the construction more or less starts now. We have kind of good idea on what the system should be doing, and we also know that we of course have to do more analysis for the design as we do construction, but the idea is that now would be the point where the programmers get involved. So we are more or less starting the construction, and that's why we are talking about agile methods today. The process itself, like mentioned on the earlier lecture, is, nothing more than just an idea or concept how software should be built. So the process defines who does, what does, when does, and how does. Basically giving sort of a framework or guidelines for software development, because software constructs are usually really complicated, and there are several things that have to be kept in mind in, at least in larger projects. So the problem with the software processes is that they basically tend to perform really poorly. The Standish Group report on different software projects throughout the world have said that every fourth software project, in this case meaning commercial projects, adapting new tools or adding new requirements or adding platforms for distribution, or simply creating new product or making a customized software for a paying customer. In every fourth project, something happens and the entire project is cancelled. On the other flip side of the coin, every fourth project is success. Everything happens smoothly. There's no problems, so to say, in the project. But the worrying part is the 49%, half of the projects, which are completed late, over budget, and or with missing features. So basically, considering that the software projects and software processes are a guideline, the processes are guideline for projects to produce software within budget, within time limits, with acceptable quality and all the required features, and still we have half of the projects basically miss that goal. Then what can we actually do to improve this situation? And that's where the agile methods come from. Basically, the idea of agile methods is that we try to ease the burden of management. The agile software development differs from the typical or traditional waterfall approach in a sense that it tries to increase the amount of communication. It tries to increase the speed on which things are done, developed, and it tries to use prototypes to get more, or something similar, really high iteration to get more close to the original idea that the customer had when they ordered something. So the typical features of agile software development are more or less that the agile projects try to minimize the risk by doing development in small iterations. It means that we only add one feature or a handful of features over a relatively stable release candidate, so that we can always roll back our development if there's some serious problem and start again by losing relatively small amount of work. If the iterations are like 1 week or even a couple of days and the idea doesn't work, the feature is too complicated to implement, or there's some other issues with like legal issues or well basically anything, we can just roll back that and be back on the last end product of the last iteration. This also means that the frequent releases are used. Even daily builds are used. That's one of the reasons why that happens, is that if we have daily builds, we can always have the newest version which can be used. And this, if it can be used, it can be tested. And basically, when the Agile methods first were, the concept was coined, in industry in the 90s, the testing work usually was something that just produced list of features which aren't working correctly. And then there was a separate development cycle at the end of the project where additional testing work and additional quality improvement was done. But for the Agile software developers, the idea was that if we have frequent releases, we always have something that works. We can test out things even during the development. Also, the customer was one of the new features that the Agile software development found out. Since the traditional idea is that everything is documented, everything is written down so that there's no doubt about what have been agreed, what's the feature that we are implementing. But in Agile development, the need for documentation was more or less replaced with the idea that if we get the customer to participate in the development or have customers who are easy to access, are able to communicate with you, then you would get more detailed, more on the point information. And not only customer, the developers themselves. The idea that the teams are relatively small, less than 10 people, working in the same premises so that we can talk to each other. If there's a problem in the code, if there's some feature which one developer does not understand, then there would be the developer who originally created that part to explain how it works, so we can avoid some problems with people misunderstanding the behavior of the system. This also promotes is promoted by the physical working space being same for all the people. So instead of using massive outsourcing, the chase the sun ideology, meaning that we have one office in Europe, one office in Asia, and one office in America, so that we can do continuous 24-hour per day development cycle. That concept was replaced by having actually one physical workplace for all the people who are involved in development, even a customer at the premises, so that the need for emails and phone calls and documentations and some sort of meetings would be minimized simply by having everyone who knows about the system in the same place, so we can ask if there's a problem. The last part, which probably isn't such a revolutionary idea, but was nowadays, but was during at the 90s when the Agile software development in large was coined, is actually the idea that the only thing worth measuring in software project was the amount of working features or working software. So the idea that how many meetings we have had, or how many milestones we have passed, or how many deadlines we have already done, or is basically irrelevant because all this is just support work to get something working done. So why not measure the amount of existing features in the current product, not the amount of work we have done for the project. So the number of software engineers, software developers, came up with the Agile manifesto at the turn of the century. It's a sort of a declaration. I'm not certain how serious it's meant to be, but some people have taken it really seriously. There's a number of people who say that the Agile manifesto was written by the devil himself, and some people say that the Agile manifesto is actually a wake-up call for the community, which has gotten accustomed to poorly performing software projects and having more administration than one medium-sized university or government for doing anything. So there's a number of ideas here given. On the picture, the four main ideas or mandates are basically the basis of the entire Agile process methods, meaning that we have interactions and individuals over processes and tools. If we are using a small team of relatively experienced professionals, we can skip the formal parts to a large degree simply by having these people use their existing experience to guide the project. Also, working software over comprehensive documentation. Well, this is something I personally agree with. And the idea was that instead of making an UML language a graphical programming language where we can design everything to the degree of variable names before implementing anything, we should probably start with a high abstract level design and then start making software and document what we have done, not what we are planning to do. The customer collaboration over contract negotiations was actually one thing that was considered really difficult to implement. And that's still a bit of a problem. Well, in many countries, surprisingly, most importantly in the United States, the problems with the legal responsibilities and legal requirements are sometimes too much to allow this sort of collaboration over a contract negotiation approach. But still, it's sort of a mindset. Instead of always going to your lawyer or going through your contract to see what you have to do and who's responsible for what, try to work with the customer so that you can both come up with, you can make an agreement or consensus on what's feasible to implement, what's doable with the resources and the time frame, and what's really necessary and what's not. Well, and the last part responds to a changes during the project instead of following a plan. It's more or less about the risk management. The Agile projects tend to usually be smaller projects which can adapt to changes, like some key people, key personnel leaving the company, or competition releasing similar products, or laws changing so that your product is now illegal to use, or things like that. The idea was that we respond to problems that emerge instead of just be prepared for everything. And if if most of those risks or problems don't materialize, then we have basically been preparing for something that will never happen. There's actually a really good TV program on National Geographic about the preppers, people who are preparing for doomsday scenarios, building their houses into fortresses and hoarding money and food and guns and stuff like that. So, considering that sometimes the plans or risk management might seem something like that, especially if we are considering things like civil wars or nuclear war as a possible risk for international software service. If there's a war going on, then I guess there's another problem besides the fact that your software project may be a bit late. Anyway, the Agile methods are, they are not a competition for traditional or more traditional approaches like waterfall or unified process, things like that. They are more or less models existing simply because there's need for them. Most of the people probably have heard about the extreme programming or Scrum approaches. But there's a wealth of more: agile modeling, adaptive software development, Crystal, dynamic systems development model, agile unified process. There's hundreds of them, but those are ones that are at least somewhat used and usually associated with agile approaches. So these approaches all try to use the ideas of agile thinking or agile approach. And today we are going to look into the extreme programming and Scrum. The extreme programming because it's more or less the most agile method when compared against rational unified process or waterfall approach, and Scrum because that's actually used to a quite large degree in software industry, because it's a sort of a sensible, easy to use approach where both the good parts of the waterfall approach, things like unified processes and also agile thinking are used. So, if we start with the definition of what's agile development. So we want to have iterations. We want to have small incremental development. We want to have testing during the development work and these sort of things. If we want to really think through all the things we already do in the unified processes and what the agile thinking in its nutshell is, then actually the rational unified process is something that can be said that it's almost an agile approach. Of course, we know that the amount of documentation, amount of preparing work before we start to do development is actually quite intensive, and there's a large amount of designs and diagrams and documentations we have to do before we actually start to do the construction work. But still, the agile approaches aren't some dark arts or black magic. It's just a way of thinking. How different models can be improved. For example, against the plan-driven methods, do we absolutely need to have the highly detailed plans? On the iterative development, why are we using iteration? What are the good parts of it, and how much design we actually have to do before we do the next iteration? Against the waterfall model, we already know that the requirements are going to change during the development. We already know that there will be some differences. So how can we answer to this problem? What are the necessary steps needed to ensure that even if we start doing the right product for the right customer, we end up with the product that's still right for the customer and does exactly what we want to do, and actually is something that's marketable and working. Finally, the cowboy coding was the software engineering method's answer to the English football national team. The cowboy coding means that we fill up our organization with people who are superstars or rock stars or whatever, and we give them this we give them freedom to work as a independent fighters or whatever, so that they can do whatever they want to, and they can design things however they want to, code things however they want to, and hope that they come up with the final product. Instead of actually following some sort of game plan, we just get a group of 11, 12, 15 superstars and hope that they find it in their hearts to cooperate and make something work. So that's actually the association with the English national football team. I say that for a country that plays so much football, the amount of world championships for them is appalling. But still, the reason is the same. They are trying to use instead of trying to do some coherent game plan, they usually tend to just get number of superstars and hope that something happens. But of course, following some sort of plan, some sort of the game plan or project plan usually tends to give better results than just getting a number of highly experienced people together and just throwing them out the door. So, the agile development, the agile methods are, they are useful, yes, but there are some restrictions on when we can use them. Like I said earlier, if we want to respond or make a software product to a market that's rapidly changing, there's lots of trends or genres or customer groups, or there's new requirements emerging, then you probably want to do Agile simply because the idea is that you start the development early, make small incrementations, and actually can make larger changes during the project. Of course, if we are creating a fighter jet or submarine or spaceship or basically anything to do with healthcare, then you probably want to have the documentation so that you have the chain of evidence that the things are actually working, and you can't really use small incremental development with things related to radiation or human lives or things like that. But of course, that's just one group of software projects. From the organizational perspective, there's also not problems, but the requirements, because the agile development, working in small teams and having less than comprehensive documentation or design, allowing people some freedom to do design, it means that, of course, you have to trust your people. You have to trust that your developers do do sane decisions, and you have to allow your developers work with the customers or the people deciding on the requirements quite freely. Like I said earlier, if the mindset is that we always run by our lawyer or contract to see what has to be done and what's necessary, then the agile methods really aren't that useful. So there's a couple of models for suitability. They sort of give you an idea where the adaptive methods or agile methods lie on the scale. This is more simplified model. This basically is model based on the amount of design before implementation or planning before implementation. On the one side of the scale spectrum, there's hackers. Basically, the cowboy coders, the hackers, the people who don't do much, if any, documentation. They just need a tool for something, they code it, create it, and that's that. On the other side, there's the inch pebble iron bound contract, meaning that it's let's say really painful government contract or military contract where you have to agree basically on absolutely everything before you can do any development. Or if you have to do even minute changes to the software, you have to get permission from your own administration and from the customer to agree that, okay, this software product is a bit different than we originally designed it to be. But basically between these two different scales, well, of course this is just this is based really on Stetson-Harrison method, where these different these points lay, basically meaning that it's just an abstract model. The extreme programming and the agile methods tend to usually be on the less design side of this spectrum. And the milestone plan-driven model, which is the traditional waterfall, is this black bar here, meaning that there's some possibility to do iteration, some possibility to have small freedom here and there, and the milestone risk-driven models like a rational unified process are towards the agile methods simply because we use iteration and things like that. So that's one way to see when we can use these extreme programming and Scrum models. The more comprehensive model could be something like this. It's basically a 5-dimensional suitability model. It has several things like dynamism, meaning that how many requirements changes do we have. If there's only 1 or 5, then probably plan-driven approach is fine. But if we go talk about things like 50, 100 changes per month, then we go towards agile. The personnel competence is also an issue here. The amount of experience, basically. The numbers and levels mentioned in the model are based on this one formal accreditation model and amount of months of experience, if I remember correctly. But basically the idea is that if you have inexperienced crew, then you need to have more design and more planning work simply because people don't know what to expect. What sort of risks or problems to expect, how some platform will behave, what sort of 3D models, how many moving objects you can have on your mobile phone screen before the system starts to seize up or the animation isn't fluent anymore, that sort of things. The criticality, like I said, what's the worst case scenario when there's a defect? Is it just comfort, we have to restart the game console? Is it some minor funds like bus ticket? Are we talking about pension plans? Are we talking about one user, multiple users? What happens if there's if the program completely fails? So if we are talking about a busload of people, then we probably want to have plan-driven approach, because we have to plan beforehand. We have to have extensive testing plans, quality assurance plans, things like that. Also, interestingly, the size of your crew is also one aspect in this model. If you want to use face-to-face communications, it's okay to do so with 5, even 10 people. If we have more than 10 people, the 12 is more or less the cutoff point where we need to have separate manager whose only responsibility is to manage the project. Also, 12 is sort of the cutoff point where we probably want to have 2 teams of 6 people or 3 teams of 4. Since if we are working with large groups of people, then if we only rely on face-to-face communications, then the only thing we have time to do during the day is talk with people. So, and also having more than 10 people at the same room at the same time in the same physical premises is going to be difficult, because someone is going to have a sick leave day and someone is going to be on a meeting and someone is going somewhere. So we need to start writing things down. And culture, this is more or less another thing from Harrison-Stetson method. How well the company is adjusted to working with uncertainty. How much chaos they like, how much order, or how much they need to know where exactly we are with the project. So these sort of things considered, we sort of more or less know if the Agile approach will work. Because, this is really stereotypical definition of these things, but if we are doing high criticality software or using junior developers, have a relatively stable requirements needs, have large numbers of developers and culture that demands order, then we are probably on a home ground of plan-driven approach or waterfall or rational unified process. Also, with the Agile, low criticality, senior developers, requirements change very often, small number of developers, and culture that thrives on chaos. Also, what I would personally add to this list, what's the home ground of Agile method, is that if the project is relatively small work, like adding one new feature to software, adding more content to existing game, for example, or making some changes to software to tailor it for new customer, basically just changing some logos and possibly adding one new feature, then the Agile method is more suitable, simply because, we already have the complex parts done and we are only doing some low criticality additions or changes to software that we already know that it functions. Okay, so the extreme programming, even though it has a bit of a silly name really, the extreme programming, the name extreme comes from the 90s culture of having extreme everything. The extreme programming here means that basically everything is development. We make really small design at the start and then start to do development. Start to develop something based on our initial design and see where it goes. The idea is that we have a small team, 2 to 12 programmers, meaning that we don't need separate layer of administration. We have so few people that we don't actually need to have this sort of follow-up meetings because we already know what everyone is doing and where everything is going. And we have access to customer, so if we need to have information on something, we can ask just them. We apply automated and functional testing and work on one working place, one office, or at least in one building, so that everyone is readily available. So this is more or less the model of extreme programming. There's some things that need to be explained. For example, the spike here means that it's really more or less just this fast design to give some form or structure or game plan for the developers. The user stories are used to gather requirements. There's system metaphor, which is basically a high-level definition. In games, it probably could be something that we decide on what platforms we are going to release our game for. In PC architecture, that would be something that we decide on what tools over what framework we will create our software. Then by doing iterations, we create software in iterations that take 1 day, 1 week, adding new features, adding new things into software, do acceptance test for the software for that iteration, accept the changes with the customer, not necessarily formal acceptance, just once per week showing the customer that okay, now this looks like this. Do you think that it's still going the right direction? And if the customer says that it's okay, then small release, basically using that version as a basis for the next iteration, or planning new features, things like that. Besides, I'll get back to that later, but yes. Basically, the planning and development and working principles are more or less really adaptive to the existing situations. We create user stories. These are basically use cases to get an idea what we want to do. Okay, so the player has a warrior which has sword in it, and they try to jump over the castle for walls to invade the castle, and these sort of things. Get the general idea on what we are doing. The customer loads up their e-card at the loading terminal at the bus station, and then uses the e-card in the bus to reduce 1 credit from their card. So, and if this works, they'll get the bus ride for free. These sort of things. And yes. The release planning, meaning that the small iterations, what features we are going to do at what iteration. First week we create movement. Second week we create the attack animations. Next week we will do the climbing animations. Then we will add the enemies and these sort of things. Our basis for the schedule. So we know that by the end of the week 4, we should have a character that can move, that can use their sword, can climb up ladders, and we have enemies which just walk around at the game. But that's our schedule there. We move people around, meaning that if there's one person who's really really good at programming and one person who's really, really good with graphics. We can change people around so that the people who are really experienced or talented can support the people or parts or components or modules which are lacking behind. This is simply because the idea is not to create a new operating system with this approach. We are talking about, video game or small library database or simple warehouse management system or net store, things like that. So we can use the experienced people to, make sure that everything functions, and if we are behind on some modules, then we can focus our good people on that. And if we find problem with our approach, people think that the iterations are too long, iterations are too short, the user stories are not clear enough, or that the requirements are not clear enough, then we can just, change things. If our developers say that we are using week-long sprints or week-long iterations, and the Friday is usually just spent playing video games and drinking beer because everything was done by the Wednesday evening, then we can, shorten the iteration by a couple of days. Although, on the other way, if people are complaining that we can't keep our deadlines, people are working through night and day because these deadlines or feature requirements for the iteration are too complicated, then we can just spread out the objectives or give people a couple of days more to come up with the implementation. And most importantly, there's a stand-up meeting at the start of each day. It's not stand-up comedy, it's stand-up meeting where everyone explains what they are doing. Well, someone might turn it into stand-up comedy simply by starting to express their feelings towards certain software tools, but let's not go there. So, the design, it's simple. It's really simple. It's something that you can draw on one sheet of A4 paper. It's, the CRC, class responsibility collaboration cards, are more or less these sort of a formal method of finding, definition for model. What we want to create, what's it doing, and with what it's collaborating. We use these spikes or solutions to reduce risks. So our entire, the extreme programming is really big into allowing people with experience or talent, using their experience and talent to drive or steer the project towards some feasible objective. So these spikes are just the way to reduce risk. Because the people developers already knowing what the platform can do, what are the libraries that are really complicated to use. For example, with Python, the tkinter, graphical user interface library, is really nice if you want to have just something running, like a couple of buttons and one output form, so that you can have graphical user interface in Windows. But if you try to do anything more complicated with it, you probably are going to, lose your mind or, really have problems with it, because the implementation of the tkinter library in Python isn't really well documented, and it's not that fully compatible with the Python programming language. You can use it, but there are better user interface libraries for Python. So by applying this sort of an insider information, they reduce risks by doing really simple design and adding some requirements. And when we get something done, or we end up with a module that's really complicated or difficult to work with, we just mercilessly have to refactor it, meaning that we take that module out, completely rewrite its functionalities, and try to make it more simplified. So, the coding work more or less requires that the customer is always available. When we are implementing things, we know that we are doing the right thing. We also have coding conventions like for variable names, for when to declare variables, what sort of commenting scheme to use. Not because it's nice and makes International Standardization Organization cry out of joy, but because we want to have a code that looks similar so that anyone can work with any code or any source code. We use pair programming so that there's one person doing the active development, the other guy or the other person proofreading the code, seeing if there's problems, trying to help the other guy with the problems. And if there's a complicated issue, then this programming pair can discuss the options and try to come up with the solution. It's found to be a really effective way to help people create source code if they have someone to work with, even if the other person is just basically proofreading the other guy's work. We do integration, and there's actually one interesting thing with the extreme programming. It's one of the only process models that definitely says that there will be no overtime. So if the developers are not able to come up with a solution to every requirement or every thing that needs to be done within that iteration, it's not because they are lazy, it's because there's a problem with the requirements, or we are trying to be too ambitious with the work. So to not completely burn out the developers, the programmers, the people working in the project, there will be no overtime so that the people don't get fed up with the project and leave your team. That's actually interesting because it's something that's really not usual in the software development. The development crunch or for the deadline is usually something that exists in almost every organization, meaning that the last couple of days or weeks before the final deadline, the people are basically living at their working place to get everything done and everything fixed. And yes, well, the testing work is unit tests, and meaning that the developers do testing work. They create the test cases, validation cases as they develop the code, and there's also test automation if there's a possibility to do so. So overall, the code ownership or working with the extreme programming looks something like this. So we create high-level definitions, do pair programming, move people around if there's some project or part which needs help. If there's a complex code, we simplify it by doing refactoring. If there's a new module or new code, we create unit tests for that part, so that when we are doing continuous integration, we can see that everything works out. And if all the unit tests are passed, then the code gets through the acceptance testing, and that iteration is functional. Of course, this doesn't take into account the problem we have if our initial design is wrong, or we are just talking about technical functionalities here. Everything works fine. If the product is not the same, then that's another thing. And basically, the planning and feedback go into large iteration loops. If we are developing code, we get the first feedback or new plans from our programming pair in seconds. When we do the unit tests for the code, that gives us feedback every time we run the unit test after changes. So it's a minute. We talk about minutes. We probably are going to talk about the next implementable thing, or how we want to approach certain problem with our partner. So that gives us feedback every hour. We have stand-up meetings once per day, acceptance tests, iteration plans, or the plans for the next features, and overall the release plan. So basically it means that we have several points in our project where we know that we are doing the things correctly. And we also get feedback and ideas on what to do. So if we have competent people, we are probably going towards the right direction. But that was the extreme programming. It's on paper it's really fine idea, but there's some problems in it. I said earlier that the testing there relies on the fact that we are doing things correctly. The extreme programming only basically relies on the fact that you have professional, experienced developers doing something for the platform they are accustomed to. Well, to put it nicely, that's probably the most optimistic or most easiest way of doing software development. Usually we have people who are not experienced with the tools, new people, old people, burnt out people, someone who doesn't care, or customer who just has vague idea on something, and we can't simply run with the simple design. So the other iteration, Agile method I'm going to talk about today is the Scrum. The Scrum is an Agile method which more or less has emphasis on how to organize the development work. The Scrum method tries to apply the Agile approaches or the Agile thinking into the development work itself. So we have iterations or sprints, as they are called in Scrum, of 2 to 4 weeks. That's more than in extreme programming, but still considerably less than, for example, in unified process, where the one iteration may be something like 3 to 4 months. We have a product backlog, sprint backlog, and burn down chart. These are just lists of features to be added to the product, plans on what we still have to do and during this one sprint, and what requirements we need to fulfill during this iteration, what was left from the last iteration. We have also some developer roles here. The product owner, the Scrum Master, so on and on. Basically, just giving the idea that we have separate people who are more or less the administrators of the project. Some person who has the final say on everything. Like in one organization where I was doing interviews, or game company, but anyway, they were using Scrum, and they basically their ideology was that the product owner was the quality manager or the quality director. The person saying basically two things. That the quality director is asked one question: is this good enough to be released or sent out to publisher or shown at our games convention or whatever? And the quality director, if he says yes, then it goes out. If he says no, then it will go back to development. The quality director is not responsible to the management or anyone. They can say no continuously, and as long as the quality director says no, then the product will be in development. The reason can be anything. The sound effects are crappy, the graphics look horrible, or the animation is choppy, or basically anything. But it says that there's one person in the project that has enough power to make the final decision and overrule everyone else if necessary by saying that, okay, this is something that we can't show or can't do or won't do or whatever. And, well, the development ceremonies, these are more or less just deadlines or happenings or events or stuff like that. So we have daily meetings, yet again. We have review meetings where the developer organization just goes through all the things that have been done, and planning meetings where we decide what we want to do in sprints. So the Scrum project doesn't actually give any restrictions or methods on gathering requirements. The requirements or use cases or just list of things we want from our product or what the customer wants is organized into product backlog. It means that it's just list of requirements or list of features or list of whatever put into these sets, which can be done in one Scrum sprint during the 30-day cycle. So at the beginning of one sprint, the development iteration, we take from the backlog one set of requirements and take also the backlog of the earlier sprints, things that are yet still undone or things that we were unable to implement because some problem, and we start our 30-day cycle. During those 30 days, we have meeting once per day, normally at the morning, where we talk about what we did yesterday, what we are going to do today, what are the main problems I'm experiencing with my responsibilities, and what I'm still going to do during this entire sprint. And when the 30 days are done, we review everything we did, put on the backlog things that weren't working, and after each cycle we should have working software and working increment to that software, meaning that this increment is the realization of this one part of the product backlog. So one sprint realizes one set of new requirements, including the design, implementation, and testing of these set features. So the requirements have to be gathered somehow by interviews interviews, surveys, just making game design document. But anyway, in one sprint we realize one set of new requirements. If they are not finished in time, they are included in the backlog, and there's usually at some point separate sprint or separate iteration, which is only just taking care of things that are unfinished or problematic. So these different artifacts are more or less just designs or documentation for how to run the development process. Product backlog is the list of requirements. Sprint backlog is more or less daily plan or plan of how to implement one item from the product backlog. And the burn down chart is the flow of events or flow of work for the remainder of the sprint. So the burn down chart, as the sprint goes forward, the chart goes shortens and burns down like a fuse in a classic cartoon bomb. That's the name of it. So we have several people, several roles. Product owner defines the features, business aspects. Scrum Master, who's the project manager, who has the authority or power to make decisions on the organization, and team, that's like in extreme programming, the about 10-ish people who are working in the same premises, in same team, same building, so they can talk to each other, they can ask help from each other. So we also have ceremonies. Well, no one calls them ceremonies really. There's ceremonies in churches and places like that. But in Scrum we have daily meeting, we have planning meeting and review meeting. So the plan, what are we going to do on the next sprint, in how the work is divided into different sprints, daily meeting so that everyone knows where we are going, and review meeting where we see how we did during that sprint and if our existing product or existing features are good enough so that we don't have to come back and do some changes for them. So Scrum and Rational Unified Process, they are really close to each other. Considering that the inception and elaboration phases are something that are probably quite identical to each other really, because the Scrum doesn't have any ideology or definitions for collecting requirements. The construction flow is quite close to each other. We have analysis, we have design, we have implementation, we have testing. So basically all the same things. And when, the deployment comes in the transition, but that's basically just one of the later scrums when we have done everything on the product backlog. Then we might have a couple of the last backlogs, things like internal quality assurance, external quality assurance, beta testing, limited release, and full release. So basically that's your deployment with Scrum. So ideally the Scrum approach applies the same best principles as Rational Unified Process, but it does it with a smaller emphasis on the documentation, having less paperwork, having more reliance on the Agile ideologies explained in the Agile Manifesto. So, the Agile methods are not always the right answer. Of course, there's projects where it's not suitable because the amount of existing plans and things like that sometimes may be a bit problematic. So, for example, the documentation is sometimes uncertain. We don't have that much details to support our development work, especially if there's problem. We also sometimes may not have clear idea on architecture. That's not a problem in certain types of projects, but especially if people are not experienced on that particular platform, there may be problems where the design calls for features which are really difficult to implement or sometimes even impossible to do with certain platforms. For example, simple things like loading, building navigator software for cars and creating it for Windows Phone system and designing it so that, okay, we get the map information and things like that distributed and downloaded from a memory card, which is nice consideration, but unfortunately Windows phones do not have memory card readers by default. Some models may have, most models don't. So that sort of problem is impossible to do. Similarly, like with creating a PSP, Sony PSP game which uses these gestures or reads the orientation of the screen, which again is nice feature in paper, but unfortunately that component is missing in the PSP handheld console. So these sort of problems. Also, if we have more than the 15, 20 developers, how do we do work in large scale if we expect the main communication method be just asking from knowledge transfer method being just asking from another developer? Also, if the people are in different places, how can we ensure that the work still happens, or how can we make it possible so that the one person doing development in Finland and the other person doing development in Australia are able to exchange information when they aren't even sleeping or working at the same time? These sort of problems. And of course, if we are doing something mission or life critical, we have to have documentation and design simply because the stakes for failing software are too high. So, the criticism mostly relies on these same things. Agile leads to lack of structure and lack of necessary documentation, requires experienced people, and is too culturally different from the normal software development. The agile projects require that people like each other. That's one of the largest problems with agile methods. It actually requires that people like their work and like each other, and we all know that's just unrealistic. People sometimes have different opinions. People may have opinions simply because they don't want to agree with another person, and they have their own agendas and stuff like that. And of course, if we are using agile methods, we may end up with a problem on actually having to negotiate a contract with certain deadlines and certain features and things like that. Some of these agile methods are simply too chaotic to be able to promise any of these things. So, in practice, it means that the agile methods are used, yes. The pure agile is rare. In most companies, there's a hybrid of agile and, the traditional approach. People applying things from agile methods, but still having the documentations and things like that. The agile practices, daily meetings, daily builds, reviews, pair programming, automation, customer and development team, they are quite usual, even if we are doing really traditional programming. And the Scrum especially is really popular in small development. It's the balance between giving the developers freedom to express themselves and having a sort of a control structure where we can sell our work, control our work, and measure our progress is something that the Scrum really supports. Okay, and well, mostly I'd say that the many organizations are using this type of project approach. The Agile methods are becoming more popular. There's 1/3 of software projects in Finland are done with the approach which the company itself calls Agile. And in many organizations, the use of Agile approaches are related to the type of project. So if we are doing the next version of our main product, we do it with waterfall approach. If we are simply just making some fine adjustments to get our existing product to new customer, tailor it for new logos, tailor it for new themes, things like that, or just adding content to existing game, then we might use Agile. The company might use Agile simply because there's not that much requirement documentation. People already know what they are doing, and they are doing it on a relatively stable platform. So why not use some simple approach to just add one new type of infantry or giant or fire dragon or whatever, your favorite mobile phone game. Anyway, well, the Agile methods, during the 90s it was said that they will replace all the traditional approaches. Well, it didn't happen. During the 80s or at the turn of the century, people were saying that now the Agile methods will replace all the traditional approaches. Well, it didn't happen. And a couple of years ago, people said that now that we have so sophisticated software tools and so small projects, the Agile methods will replace all the traditional software development processes. And I say that it still won't happen, but still the Agile thinking or Agile practices are something that has really changed the software development work during the last, 20 years. But anyway, that's for this week, and I'll see you next week when we are talking about software testing and how software is tested, and actually talking about the real life examples from our research projects in Finnish software industry. Okay, thank you.